Welcome back. All right, here we go. Bells ringing, starting class. So we might as well start our lesson. So I am on lesson 4. In module 4, I'm on page 25. Percent increase and decrease. All right, essential question says, what are the key words used to determine if a problem is a percent increase or decrease? All right. So if we take a look at what we have in our opening exercise, and usually I skip these and wait for class, but in this particular case, I need the data and information from it to be able to do our lesson. So Cassandra likes jewelry. She has 5 rings in her jewelry box. So it says to sketch the 5 rings. I'm not very artistic. So those of you who are artsy, have a good time with this, but I am not. So my 5 rings are going to be pretty plain and blah. There are the 5 rings. Ooh, ah. I know my artistic ability is incredible if you want to add embellishments to it, but there's my 5 rings. All right, well, it says to draw a double number line diagram to be able to help us figure out these things. It's basically a tape diagram. So I'm going to make mine into a tape diagram. I'm just going to have the top of the tape represent the percents and the bottom of the tape represents the data. All right, so the top is going to represent percent. I've got 100% here. And I'm going to split this into the 5 sections. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So I've got 5 sections. So that means that each one of these is a 20%. 20, 40, 60, 80, 100%, right? And each one of those spots represents a different ring. 1, 2, 3, 4, all 5 rings. Okay? So a double number line, if you want to draw it as a tape diagram, it'll make sense to you guys as well. Okay, so what percent is represented by the whole collection of the rings? So the whole collection is 100%. Well, then what percent does each ring represent? Each ring is 20%, right? Ring 1, ring 2, 3, 4, and 5. Each one represents 20%. And I need that to be able to keep going with my example here. So Cassandra's aunt said that she will buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her collection? Well, 1 ring, right? 1 ring, we just said, was 20%. So in other words, she's going to have a 20% increase. Okay, each ring was 20%. Pretty straightforward, pretty easy. All right, let's go to page 26. Here we go. John increased his trading card collection by 5 cards. He originally had 15. What is the percent increase? Use the equation quantity is equal to percent times whole, which we've been using, to arrive your answer, and then justify your answer using numeric or a visual model. All right, so here we go. Part A, use the numeric or visual model to find the percent increase. So what we're going to do, we are going to, let's see here. We're going to have our 15 cards, right? This represents 100%, and we have 15 cards. And he's going to increase this another 5 cards, right? We're going to increase this another 5 cards, which means we now have 20 altogether, right? So if I break this original one up, I could break this into sections of 5, right? Here's 5 cards, here's 5 cards, here's 5 cards. That gives me my 15 plus the 5 more that we have. In other words, each one of these, right? This is 5, 10, 15, and then 20. But if I did it as a percent, this is 33.33%. This is 66 2/3%, and then 100%. Okay, so there is our visualization. So if this is another third, this would be 100 plus the 33.33%. Right? So So in other words, he's getting another 1/3. All right, let's do this using some algebra here, using our quantity, which is equal to the percent times whole. And if we plug that in, our quantity, let's see here, he has what? 5. The percent is what I'm trying to find. So I'll just call that P. And then the whole was 15, right? So let's figure out what this is by dividing by 15 so that I can solve for P. 15 goes into 5. I'll just reduce this. This becomes 1/3. Change 1/3 to a percent, and it's 33 1/3%, which is what I had set up at the top. So this is a percent increase. He increased this 33 1/3. Okay. Based on your answer to part B, how is displaying change as a percent useful? Well, all right, I could see how much it increases. It's a proportion. It's proportional for me. All right, let's jump over to this problem next. We have a sales representative is taking 10% off your bill as an apology for any inconveniences, right? Maybe you're at a restaurant and it was a bad situation. Something bad happened. You got sick or whatever. Or they spilled, hot soup all in your lap. And so they're like, we'll take 10% off. So what does this mean? What do you think this means? Okay, I want you guys to hit pause and just kind of jot down what's going to happen in this situation. So these are some things that you may have written down, that it was a 10% discount, there's a 10% reduction, there's a 10% decrease. Any of those, they all kind of mean the same thing. So as long as you said something in that frame of mind, you probably have it right. So I want to know, based on what we just said there, let's take a look at what's going on in this, right? We're getting this 10% off your bill for spilling this hot soup in your lap, and then we apologize. Is that those two statements there in those boxes, are they true? Are they equivalent? So the first one says, well, that means I'm going to pay 90% of my bill. And then the other person says, well, 10% of my bill will be subtracted from the original total. Are those two statements, right? Are these two the same? I don't know. Okay? So in other words, what they're saying over here on the first one, on the left-hand side, is that the new bill, right, mathematically, they're going to take 90% or 0.9 of the original, right? That's what they're saying in that one. Is that the same thing as saying 10% off? So let's take a look at the other one. We have our new bill. And they're saying 10% will be subtracted from the original. So we have the original, and we're going to subtract 10%. 10% we know is 0.10 of the original. Are those two things equivalent? Well, let's take this one on the right-hand side and kind of mess around with it, because the other one's pretty straightforward, but let's look at what's going on. So the original bill is 100% of the bill, right? The whole thing. So in other words, I could think of this as, let's use B for original bill. So our new bill is going to be equal to 1 of the originals minus 0.10 of the original bill. Well, I can undistribute, right? These both have B in common, right? They both have a B. So what I'm going to do is undistribute or factor out the B, and I'm going to have 1 minus the 0.1 times B, because they both have that in common. Well, what's 1 minus 0.1? What's 0.9 times the bill? Well, let's go over to the other one. This is, according to our rule, 0.9 times the bill. And what do you notice? I notice that those two are the same. So since I'm getting the same thing, these two statements are equivalent. These statements are equivalent. So you can look at it and solve it either way. Okay, you can take 90% times and get the new bill, or you can take the original and subtract 10% off. And sometimes one way is actually faster and more convenient than the other way. All right, page 28. Ken said that he is going to reduce the number of calories he eats during the day. Ken's trainer asked him to start off small and reduce the number of calories by no more than 7%. Ken estimated and consumed 2,200 calories per day instead of his normal 2,500 calories per day until his next visit with the trainer. Did Ken reduce his calorie intake by 7%? Justify your answer. Well, I'm just going to kind of estimate here a minute, okay? So easy percentages to work with is 10% and 5%. Okay, if I can find 10%, I can automatically get 5% and then just kind of know what's going on from there. So 10% of 2,500, right, means I'm going to take 0.10 of, tells me to multiply, 2,500. So in other words, 10% means he should reduce his intake 250. Okay, that's 10%. Well, 5% is half of 10%, right? 5 is half of 10. So really, all I'm going to have to do is take half of my answer from up above. Half of that will give me my 5%. So if I know 10%, I can find 5% very easily, and it is 125. So in other words, Ken should be somewhere, my answer should be between 250 and 125. And if he doesn't meet that requirement, then nope, it doesn't work, okay? And if he's above 10%, then he's reducing too much. All right, so let's take our quantity is equal to the percent times whole. Just write that down every time, guys, okay? So we know that, let me step back a second. It said that he had to reduce this by, what, 7%? So 7% of the whole thing, which was 2,500. Well, I can't work with the 7, so I've got to change that over to a decimal. So 0.07 times 2,500. And I find out that he should reduce this. That's 175 calories. What did the doctor say he should have, or the trainer say? The trainer said he should have no more than 7%, and he dropped it 2,000 to 2,200. So let me see. He had 2,500, and he is now doing 2,200. That's 300 calories less, right? He's having 300 calories less. So in other words, this quantity should have been 300, or he's been doing 300, and instead of 175, okay? So is he doing this correctly? No, he's not. Boo, poor Ken. So let's see here. Another way we could have solved this, you could have said, all right, he's been taking in 2,200 calories, and instead of using 7%, I'm going to take 100% minus the 7% and get 93%. He should eat 93% of what he has been, 2,500 calories, okay? And we find out that 2,200 is not the same as what he really has been doing, 2,325, okay? So no, he's not doing this correctly. He's not following the trainer's recommended procedures. All right, let's take a look at exercise 2. Skylar is answering the following problem. The value of an investment decreased by 10%. The original amount of the investment was $75. What is the current value of the investment? Skylar said 10% of 75 is $7.50. And since the investment decreased that amount, you have to subtract $7.50 from 75 to arrive at the final answer of $67.50. Is he right? Well, what we could do is we could try to figure out if this is true. So let's see. We're going to say that our final investment, at the end, is going to be X. And we had 100% minus the 10% times the $75 investment. In other words, 1 minus 0.1 is 0.9 of 75. And sure enough, when we do it this way, we get $67.50. Okay? We could do it the other way. Some of you would rather do it the other way, in which you are saying, okay, let's take our investment of $75 and let's subtract 10% of that $75. All right, and either one is going to get you the right answer. It's fine. This is what Skylar was saying to do it. So when we go through and solve it this way, sure enough, we get $67.50. So either way, you can take 90% and go straight to the answer, or you can take the 10% and subtract from the original. Either one's going to get you there. Use the one that makes your brain make sense, okay? So let's take a look at this table. Skylar wanted to show the proportional relationship between the dollar value of the original investment, X, and its value after 10% decrease, Y. He creates the table of values shown. Does it model the relationship? So if you take a look, 75, he wrote 7.5. 100, he got 10. 200 became 20. 300 becomes 30. 400 becomes 40. Are those all 10%? Yes. This is the percent off, right? This is the percent off or decrease. But do I know what it's actually worth after the fact? No, okay? So we could actually add another column and ask, what is it worth? Right? If I wanted to know what it was worth, I would have to take 75 minus 7.5 and get 67.50. Or I could take 100 and subtract 10 and go, okay, well now it's really only worth $90. I've lost money. Or 200, subtract the 20, and it's now worth 180, right? That's what I want to know. Oops, excuse me. What is it worth? So it depends on what you're looking for as to what you want that table to do. Do you want to know how much you've lost, right? This column here says, I'm losing this money. This column here says, how much money do you still have left? All right, page 30. So Justin earned 8 badges in Scouts as of the Scoutmaster's last report. Justin wants to complete 2 more badges so that he can have a total of 10 badges earned before the Scoutmaster's next report. Okay, if Justin completes the 2 additional badges, what will be the percent increase in badges? All right, so the 2 is our quantity. Our percent is what we don't know. And the whole, in this case, starts with 8, right? He's starting with 8. We can't say how many he wants at the end. All right, so let's just go ahead and plug this in. Quantity is equal to percent times whole. So we'll just plug these all in. 2 is equal to our percent times 8. Divide everything by 8. And he's going to have 1/4 of an increase, or 25% increase. All right. Express the 10 badges as a percent of the 8. So in other words, quantity in this case is now 10. Our percent is still unknown, and the whole is still 8. So quantity is equal to percent times whole. In other words, 10 is equal to P times 8. Divide everything by 8. So 10 divided by 8 is 1.25. So P equals 1.25. or 125% increase? Does 100% plus the answer we had in part A give me the answer in part B? Yes, it does. Okay, 100% plus the 25% in part A does give me 125%. Well, what is 100%? 100% was, a minute ago at the very top, was a whole, right? Was 8. And the 25%, that was 2 more. And 8 plus 2 is 10. So it does make sense. This all works. So the 125% increase is just the 25% more that he's getting plus the 100 that he had to begin with. All right, example 4. The population of cats in rural neighborhood has declined in the past year by roughly 30%. Residents hypothesize that this is due to wild coyotes preying on the cats. The current cat population in the neighborhood is estimated to be 12. Approximately how many cats were there originally? Okay, so I'm kind of curious. What am I trying to find? I'm trying to find how many are left, right? Actually, I want to know how many there were to begin with. How many, and do I know the percent? Well, I know there's a decrease, right? I know we're having a drop in them, so that's not a good thing. And what does it say? 30%, right? It's dropping 30%. So that means what percent are left? So if I have 100% of the cats minus the 30% that have disappeared, I have 70% are left, because that's what I want to know is how many were there originally. Okay, so now how many cats do I have now? That's my quantity. There's my Q. So my quantity is equal to the percent times the whole. I don't know how many there are. It's unknown. So the quantity, my 12 cats that I started with, is equal to the 70% times my unknown. Well, I can't use that percent that way, so I'm going to change it to a decimal and then divide by that decimal to figure out how many was my whole. 12 divided by 0.7, grab your handy dandy calculator, and you get 17.1. Well, I can't have 0.1 of a cat, and it said it's approximately or roughly 30%. So we're going to say this is roughly 17 cats. There used to be 17 cats. 5 cats have disappeared, suspected to have victims of the coyotes around. All right, kind of a sad, depressing problem, isn't it? Lou's math class, or it's Lou's math score, excuse me, on her achievement test in 7th grade was 650. Her math teacher told her that her test level went up by 25% from 6th grade. What was Lou's test score in 6th grade? All right, so this is a percent increase, right? Because it literally says it went up. So we know this is an increase. So our quantity in this particular situation is 650. Our whole is what we don't know. We don't know what it was last year in 6th grade, okay? We don't know the 6th grade score. And that's what we're trying to figure it out, because it's what we're comparing it to. So let's start our equation. Quantity is equal to percent times whole. So our quantity in this case was 650. The percent is 25%, right? Because that's what they told us, 25%. So we're going to change that to 0.25 times our whole, or the 6th grade score. I'm going to divide everything by 0.25. And when I do that, I get an answer of, oh, excuse me, what was the percent increase? Step back a minute. This should be, went up 25%, so that means it's 100% plus the 25% that it went up, so it's 125%, or 1.25. My bad. I apologize. I didn't see that in my notes. So we'll change all those to 1.25s. Okay. So now when I divide by 1.25, her score in 6th grade was 520. Okay? All right. We will go through the closing and the summary in class. See you all when you get to school.